Hey everybody, hope you're doing well. Today's Tuesday, and today's going to be a work day to turn in your gravity notes problems and also to get caught up on your learning targets if you're not finished with those yet. You should be done with or be in the process of completing learning targets 1 through 5. So make sure you're doing these with your keywords, rating yourself, giving your grade for how you feel you understand that concept. And remember that this is more for you than it is for us. This is for you to try and figure out, do I have a good understanding of this? And by doing these learning targets, you're demonstrating to mostly to yourself that you have a good understanding of these. So if you don't understand them, go back to your notes and rewatch the videos, look at the notes, and make sure that you're understanding and asking questions of your teacher when you do have some questions. Okay, so get those 5 learning targets done. And today, what I want to do is just go through the gravity notes problems just to make sure that you have correct, accurate notes. Okay, so the law of gravity, the big thing that you should have noticed from the notes was that the force of gravity, how strong gravity is, depends on two variables, two things. They are mass and the distance between the objects. Okay? Now, one way that I think about gravity is it's kind of similar to how magnets work. If I have two magnets and they're both very massive magnets, okay, there's going to be a much greater force of attraction between those magnets. Whereas if I have really tiny magnets that with smaller masses, those magnets aren't going to attract very much. Okay? And then with distance, okay, just like a magnet, the farther away I put those magnets, the less attractive force they have. The closer I push them together, the stronger that force gets. And the same thing applies to gravity. Okay? So, the first thing that we want to take a look at is this part here. It says label which pair has more or less gravitational force. Okay? Now, I see that these all look like they have the same mass, just they're the same size, so I'm going to assume that they're the same mass. But what's different between these is the distance between those two objects. This first pair is much farther apart, so it's going to have a less attractive force. The second pair is going to have more attraction of gravity. In the second set, they look like they're the same distance apart, but what's different here is that there's a bigger mass. One of these has got a bigger mass. So that one is going to have more gravitational force than this first pair. Okay? Let's go on to the apply it part. It says two stars of equal mass are 10 million kilometers apart. What happens to the gravitational force attraction between them if the stars move twice as far apart? Okay? Well, just like in this first example, okay, if they move twice as far apart, if they move apart from each other, there's going to be less gravity between them. There's going to be less gravitational force. If one of the above stars has an increase in mass, what will happen to the force of gravitational attraction between the stars? Well, just like this example, if there's a greater mass, there's going to be a greater pull of gravity. So there's going to be more gravity or more pull from gravity in that situation. Okay. The summary question says describe the universal law of gravitation. So I'm just going to write my sentence starting with that. The universal law of gravitation states that any two objects are attracted to each other if they have mass. Okay, so anything that has mass is going to be attracted to something else. I'm attracted to the pencil that I'm holding. I'm also attracted to the earth. Okay, there's a much bigger pull between me to the Earth than me to my pencil because the Earth is much more massive. Okay? But there is gravity between everything, whether it's the size of a planet or it's the size of a pencil. Number two, what two variables affect gravitational force and how do they affect the strength of the force between the two objects? Or what is the relationship? Okay, so the two variables that we talked about are mass and distance. Okay, so I'm going to say as mass increases, what's that relationship to gravity? Well, if mass increases, gravity also increases. Okay, the second variable is distance, so as the distance between them increases, what happens to gravity? Well, if they move farther and farther apart, there's going to be less and less of an attraction, so gravity will decrease. Okay, or the force of gravity will decrease. Okay, so here in the practice problems, these are pretty much just straight from your notes. Gravity is the attractive force between the two objects. Number 4, now this is where people start to tune out here. They see this equation and they're like, whoa, where's all this math coming from? You don't have to do a whole lot of math here. You just need to see the formula and just kind of understand what it's telling us. Okay, F stands for the force, the pull, or the attractive force between them. This G is called the gravitational constant, and that is just a number that never changes. Okay, it's just kind of the way it is. That's the number that they've calculated, and we always use that number when we're calculating the force of gravity. Your mass 1 and mass 2, refers to the mass of the two objects that we're calculating the force for. And then D is the distance, and the distance would refer to the distance that's in between the two objects. Okay, so we're just going to use that formula to try and get a little bit better understanding of this relationship. So number 5, which variable of the gravity formula does not change? Well, that is this one here, the gravitational constant. Number 6, what happens to the force of gravity between two objects if the mass of one of the objects is doubled, but the distance between them stays the same? So if I look at my formula, okay, if my distance stays the same, but my mass, if one of these doubles, okay, well, if I double one side of the equation, I have to double the other side of the equation, okay, because that's what makes it an equation. It makes it equal. So if one side goes up and doubles, the other side of the equation is also going to increase or double as well, okay? So the force of gravity is going to double. Okay. Number 7, what happens to the force of gravity between two objects if they are moved closer to one another? Okay, well, I mean, we can kind of think of this as back in the notes. We know that if the distance is less, then there's going to be more of a pull. But if we also look at our equation here, if this D gets smaller, okay, that's going to cause this F to go up. Okay, now don't worry too much about that, but for you math people, you might be able to see that relationship there, but you don't really have to use the equation to figure this one out at all. Okay, so what happens to the force of gravity if they move closer? Force of gravity is going to increase. Okay, number 8, a semi-truck, 10,000 kilograms, and a Mini Cooper, 1,000 kilograms, are traveling down Highway 3. which would have a stronger gravitational force to the Earth? Okay, well, the mass of the Earth isn't changing, but the semi-truck is much heavier than the Mini Cooper. So if there's more mass, that means that there's going to be more pull to the semi truck. That force between the truck and the Mini Cooper is going to be much stronger than the force of the Mini Cooper. So the semi truck. Okay. Now the Y is because the semi truck has a much larger mass. Okay, number 9. You and your friend got tickets to a Taylor Swift concert. You are in the front row and they are in the fifth row. How would your gravitational force to Taylor Swift be different from your friends in the fifth row? All right, now if you're a huge Taylor Swift fan like me, I've been to 2 shows, and you better not tell anybody that, but I've been to 2 shows. Now, I would be very jealous if somebody had front row seats, but in this example, I'm in the front row, and they're in the fifth row, so I'm much closer to Taylor Swift than my friends in the fifth row. So my distance is much closer, so my attraction is going to be much greater. Okay, so my gravity be more gravity between me and Taylor. Okay, the reason why is because we are closer to Taylor because we're in the first row than my friends in the fifth row. So what's different here is the distance. The distance is smaller, so the gravity is greater. Okay. If you got any questions, email your teacher and check over your notes, and we'll